AP Calculus AB, here's another example, given a function, trying to apply some calculus theorems to it. A car company introduces a new car for which the number of cars sold, so number of cars sold, this is talking about total, is modeled by the function S of t, where t is the time in months. T being the time in months is pretty important. Find the value of S prime of 2.5. There's a calculator icon here, so we can do this quickly. Using correct units, explain what this value represents in the context of the problem. So if I type into my y1, this function here, and type into y2, n deriv of this function, evaluated at 2.5, I am going to get 133.333. I need to label this. S is measured in cars, and T is measured in months. So this is cars per month. Explain what this means. Well, this means at 2.5 months, the total cars sold is increasing by 133.333 cars per month. That is what's happening at that instant, at 2.5 months. It's going to change because this is an instantaneous rate of change. B, find the average rate of change of cars sold for the first 12 months. Indicate correct units of measure and explain what this value represents in the context of the problem. So we got to find the average rate of change, indicate correct units, explain what this means. Average rate of change for the first 12 months is going to be S of 0 minus S of 12 over 0 minus 12. Using a calculator. So I've got this typed into y1, go to my table, type in 0 and type in 12, see what the y values are. I got 150 and 1,307.143. 0 minus 12 is negative 12. It's going to give me negative 1157.143 over negative 12, which is 96.429. And I guess technically, since I rounded, I would say this is approximately. Indicate units of measure. S is cars, the bottom number is months, so this is cars per month. Explain what this represents in the context of the problem. For the first 12 months, an average of 96.429 cars were sold per month. Part C. Is it possible that a value of C between and including 0 and 12 exists such that S prime of C is equal to the average rate of change? This right here is the mean value theorem. Give a reason for your answer, and if the number exists, find it. So first of all, is it possible? Give a reason. Find the value. So we got three things to do. In order for the mean value theorem to apply, A, this has to be a continuous function on the interval from 0 to 12. The only value of t that doesn't exist is when t is -2. That's not on this interval, so we would say this is continuous. S is continuous. On 0 to 12. Is it differentiable? Well, if I were to find this derivative, if I distribute the 300, the derivative of this first term is going to be 0. This is going to use the quotient rule, which is going to make the denominator t plus 2 squared, which is going to make it not differentiable when t is -2. It's not on this domain either. So we could say S is differentiable on the open interval 0 to 12. So, first question was, is it possible that a value exists? Shouldn't say, is it possible? It should say, is it guaranteed? Not, is it possible? It's always possible. Therefore, the mean value theorem guarantees a value of C such that S prime of C is going to equal the average rate of change, which is S of 0. Well, let's just answer the question. Equal to the average rate of change. And then it says, so we gave a reason, we said it's the guarantees it happens, now we know how to find the value. So we got to take the derivative we got to set it equal to the average rate of change, which we said was 96.429. Now we can do this work by hand. We don't have to because we have a calculator. So if you were to put, and this would not be part of your work, but if you were to put into y1 the original function, 300 and then 5 minus 9 over t plus 2, and put into y2, hey, take the derivative with respect to x of this fella. I won't do that. I'll say of y2 evaluated at x, that's taking at all values of x, and then to y3 putting in 96.429, making sure these two are on, figure out where these two intersect each other in between 0 and 12, and you would find that this happens when C is 3.347. The units here is months. Happens in another place as well, but that's not in the domain. If you want to do this by hand, you can. You just got to find the derivative of this, set it equal to 96.429. Gets kind of be a mess there. That concludes that example. We will do one more given a table of values.